Hello everyone, welcome to our technical podcast. Today we are going to discuss a very important machine learning topic called overfitting versus underfitting. I'm your host Sakshi and today we have today we are discussing about overfitting, fitting, we'll be understanding topics. Hello everyone. Overfitting and underfitting are one of the most important concepts in machine learning because they directly affect model and accuracy as well as outcomes. So before discussing overfitting versus underfitting, what exactly is fitting in machine learning? In machine learning, fitting means training a model using the data so that it can identify the patterns and make predictions earlier. So you're saying it should generalize a data set that is not trained. A good machine learning model should learn the patterns without memorizing it. So then it can predict better. So now, what is underfitting? Underfitting happens when the machine is too simple to learn the model or the patterns in the training data. So what if the model fails to understand the data? Exactly. For example, imagine that you are trying to represent a complex curved relationship using a straight line. The model is unable to catch it and the important information from the data set. So it will not be able to predict it. Also that can be. So what causes that? Some causes are like modern skills. There are less features and insufficient training, or poor feature selection, or like high bias in selection of the data. So what do you mean by bias? Bias refers to error caused by incorrect assumptions in learning algorithm. So high bias usually leads to underfitting. So now let's discuss overfitting. What is overfitting? So overfitting happens when the model learns the training data very well. Like it includes noise and unnecessary details. So that's when overfitting. So it instead memorizes the data. Yes, example it's taken for a student. It's like memorizing previous exams. Answers without understanding the concepts. So when the moment the question comes, there's a slight change, it will forget everything. It's complete collapse. So very beloved educational tradition that is. So what are the causes of overfitting? Common causes are that the model is too complex or excessive training and noises in data, too many features, small data set, all those are common causes. So is this a real world example? So it's better to understand. Yes. So imagine a teacher is like preparing students for their exam. When it comes to underfitting, the teacher only explains the basic concepts and skips the important concepts. So when student appears for the practice, he fails both practice tests and final exams. But in overfitting, the teacher explains every previous year's question paper exactly as they are appeared before. But students score good in practice tests but struggles for the final exams because when there's new concepts appeared, he cannot answer those questions. When it comes to perfect fit, the teacher explains concepts properly so students can solve both the questions, both and unknown. That's when they can. So what are the ways to prevent underfitting? Okay, some methods include like increase model complexity, add elaborate feature, or train for more time, and like reduce regularization, better algorithm. Also, now what are the ways to prevent overfitting? Okay. They also include many methods that like use of training data, apply regularization, remove unnecessary features or noises, use cross validation, and limit stopping of the thing and compounding neutral techniques. So I often hear about bias variance data. What is it? So it is the balance between the underfitting and overfitting. Like high bias is underfitting and high variance is overfitting. So the goal is to find the balance between both the variants. So achieving that accuracy means balancing between overfitting. Exactly. Meshing is basically the art of making a model smart enough to learn, but not dramatic about it. So enough to memorize every kind of detail. So you talked about problems and causes of overfitting. So which error is usually associated with it? The error is eye variance. And what about underfitting? It might be eye bags. Can you tell me which is worse, overfitting or underfitting? Both are problematic. But overfitting is more common in complex machine learning. That was a good talk. Can you also tell me about some real-time applications of overfitting? Yes, they are important in when you diagnose system or recommendations, fraud detection, self-driving cars, and AI chatbots. That was an excellent discussion on overfitting versus underfitting. I hope you guys understood the causes and solutions regarding that. And thank you, Krishna, for discussing that. Yes, understanding this concept is very important for building an accurate machine learning model because it depends on balancing the overfitting and underfitting properly. Thank you for having me. Thank you guys for listening to the podcast. Hope to see you guys in the next episode.